Unit 4.5 Quadratic Equations. In this unit, we're going to learn how to solve quadratic equations by factoring and by graphing. In the last unit, we learned how to factor a quadratic trinomial expressions such as x squared plus 3x plus 2. We then use the sum of factors strategy to change this trinomial expression to x plus 1, x plus 2, which is known as the factor form. These two are the factors of this trinomial expression. In this unit, we're going to learn how to solve a quadratic equation like this. We have then to make use of the factor form to help us solve it. Remember, this is an equation because we have an equal sign here. Well, this one is a expressions. They don't have any equal sign. The next things we're going to learn in this unit is how to make use of graphing to solve a quadratic equations like this. Before we learn how to solve a quadratic equation, we have to understand the concept of the zero of a function. It is easier for you to understand what a zero of a function is by looking at its graph. When the graph of a function, in this case the blue curve here, intersects the x-axis, which is this one, the x-axis, or you can write it in terms of f of x equals 0. So when the graph intersects with the x-axis, these two are actually the x-intercept. And in this case, it is 3, 0, and 6, 0. Here's the value of x, which will give you a y value which equal to 0, or f of x equal to 0. We call this value of x the zero of the functions. So in this case, 3 and 6 are the zeros. The concept of the zero of a function is very important in solving a quadratic equation. Remember, when we solve a system of two linear equations, such as y equal to x plus 1 and y equal to negative 2x plus 3, we can solve the system graphically by drawing the two lines and look for the intersection, because the intersection is the solution for the system. We are applying the same concept in solving a quadratic equation. For example, if we have a quadratic equation, x squared minus 3x plus 5 equals 3, we can solve it graphically by converting this quadratic equation into system by setting both sides equal to y. So we have y equal to x squared minus 3x plus 5 and y equal to 3. So graphically, we can graph the quadratic functions like this, which is y equal to x squared minus 3x plus 5. And then we draw the line y equal to 3. Then the intersection point here is the solution for this system. Then you see the x value here is 1 and 2. Remember, we make up the y's to change the whole thing into system. So we care more on the values of x, which is the solution for the quadratic equation here. So let's plug in 1 and 2, see if it's equal to 3 here. So if we have x equal to 1, I want to prove if it's equal to 3. So put down 1 here, 1 squared minus 3 times 1 plus 5. Yes, it does equal to 3. And we can also try 2. 2 squared minus 3 times 2 plus 5. And yes, it's also equal to 3. So the solution here is x equal to 1 and x equal to 2. Or we can also do this. When we have a quadratic equation like this, we can convert it into this one by subtracting 3 on both sides. So right now we have x squared minus 3x plus 2 equal to 0. This equation is exactly the same as this one. Right now, by graph, we can see that the parabola is going to be like this. And this is y equal to x squared minus 3x plus 2. And this one, of course, y equal to 0, which is the x-axis. And look at that. These are the x-intercepts, which is 1, 0, and 2, 0. And 1 and 2 are the zeros of this equation, which are also the solutions of these equations. In other words, when we solve a quadratic equation, we can set it to equal to 0 and look for the zeros, which are the solutions of the quadratic equation. Now that we know the zero concepts of a function, we can make use of that as well as factoring to solve any quadratic equation. Here is zero product property. What it means is, if a times b equals 0, then a is equal to 0 or b equal to 0. Based on the zero product property, we can expand these two variables, a and b, into an algebraic expression. For example, we can expand a to x plus 1 times the b, say x plus 2, equal to 0. Then x plus 1, which is a, is going to be equal to 0, or b, this time is equal to x plus 2 equals to 0. Let me give you another example. If I have x plus 3 times x minus 4 equal to 0, then we can conclude x plus 3 is equal to 0, or x minus 4 equals 0. And when we solve it, we know x is going to be equal to negative 3, or x equal to 4. These x values, x equal to negative 3 or x equal to 4, are the zeros, or the solutions of this factor form of a quadratic equation. Now, based on the concepts of factoring, zeros, and the zero product property, we can now solve quadratic equation. Here's an example. You are asked to solve this quadratic equation. First, we can just factor this quadratic expression by using the sum of factors strategies. We look at the factors of the c, which this time we pick negative 2 and negative 3 because they add up to become our b value, which is negative 5, and that's why we have a factor form like this. Once we have the factor form, we can make use of the zero product property because it's equal to 0 here, so we can conclude x minus 2 equal to 0 or x minus 3 equal to 0. Then we can solve for x, and it gives us the solution of x equal to 2 and x equal to 3. These are the zeros, or the solutions of the quadratic equation right here. You can also solve a quadratic equation by using your graphing calculator to do the graphing. Here's an example. you're asked to solve these quadratic equations. So the first step, we set the y value equal to 0 by subtracting 15 on both sides, which you end up getting this equation in the standard form. Then you use the zero function of the cal feature in your graphing calculator. Then you will find x equal to -5 or x equal to 1.5 from your calculator. I'm going to show the whole process to you in the next clip. To graph the quadratic functions, you have to hit y equal. If you have something inside your calculator, hit clear, enter. Do the same thing, clear, enter. Once you clear everything, you can start entering your quadratic equations. So it is 2x squared plus 7x minus 15. And then you hit graph. If the graph doesn't turn out the way that it should be, you might want to hit zoom and then hit standard. Then you have a graph like that. Now you hit second, cal, and 0, and they will ask you the left bound. So you have to locate the left bound by pressing the arrow key until you see the blinking, and then you move to the left of the zeros and hit yes, that's the left bound. They ask you right bound, so you use the arrow key to move to the right of the 0. Then they ask you to guess, you hit enter, yes, that's the 0 you got there, x equal to -5. Then use second, cal, 0 to find the second 0. You use the arrow key, this time go to the left of the second 0. So left bound, yes, hit enter, right bound, so move the arrow key to the right of the 0, hit enter, yes, guess, yes. So here you are, the 0, the next 0 is x equal to 1.5.